Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll use the concepts of derivatives to solve this optimization problem. So as per the problem, determine the area of the largest rectangle that can be inscribed in a right triangle if the legs adjacent to the right angle are 5 centimeter and 12 centimeter long. The two sides of the rectangle lie along the legs. So in this problem, we have to find the area of the largest rectangle that can fit in a right angle triangle. And in the right angle triangle, the legs adjacent to the right angle are 5 centimeter and 12 centimeter long. So we can start by drawing a diagram for this problem. So we'll start with the right angle triangle whose legs are 5 centimeter and 12 centimeter long. So this is a right angle triangle, and in this triangle the vertical side is 5 centimeter long because this is the shorter side that I've drawn in this triangle, and the horizontal side is 12 centimeter. Now we have to find the area of the largest rectangle that can be put in this right angle triangle. And as per the problem, the two sides of the rectangle lie along the legs. So the two sides lie along this side length and this side length. So the biggest rectangle that I can fit in this right angle triangle would look something like this. So we have to find the area of the largest rectangle that can be fit in a right angle triangle with legs of length 5 centimeter and 12 centimeter. So for ease of reference, we can label the points in this diagram. So let's assume it's B and then C and then D, E and F. So the rectangle in this diagram is BCDF. Now we have to find the biggest rectangle that we can fit in this right angle triangle. So here we have to use variables for the length and the width of this rectangle. So let's assume the length of this rectangle is x, so the distance from C to D. And let's assume the width of this rectangle, the distance from B to C, is y. Now we are given that this is a right angle triangle. Now in this triangle, we are given that side AC is 5 centimeter, and we assume that the side BC is y centimeter long. So that means side AB will be 5 minus y centimeter long. Similarly, side BF of this rectangle is x units long. Now in this triangle, this angle theta will be equal to this angle here theta, because in a rectangle opposite sides are parallel to each other, and the side CD of the rectangle lies on side CE of the triangle. That means CD and CE are parallel, so therefore BF and CE are also parallel. So these two angles theta are the corresponding angles or angles in an F pattern. So the F is made like this. So this is the F pattern. So now, as per the trig ratio tan, so tan theta for angle E, so I can write tan of angle E will be equal to, so we know the formula for tan is opposite side over adjacent side. So for angle theta at E, the opposite side is AC, which is 5 units long, and adjacent side is CE, which is 12 units long. Similarly, for tan of angle F, so here, now triangle ABF is a right angle triangle because BF is parallel to CE, so therefore angle B is also a right angle. So for angle F, so tan is equal to opposite over adjacent, so 5 minus y over x. And we know that angle E is equal to angle F, and both are equal to theta. So tan and tan of E is equal to tan of F. So as a result, so 5 over 12 is equal to 5 minus y over x. So this is the equation we get for x and y using the given lengths of legs in the triangle. Now we have to find the area of largest rectangle, so maximum area, and for that we'll start by writing the formula for area of a rectangle, which we know is length times width, and the length of this rectangle is x and width is y, so the area will be equal to x times y. Now we have to isolate x from this equation that we got from the tan ratios to do the substitution for x. Now we want to do the substitution for x because it will be easiest to isolate x from this tangent equation. So our first step is to cross multiply the denominator in these equations. So we cross multiply the 12 and cross multiply the x. So we get 5x equals 12 times 5 minus y. Now we can distribute the 12 into the parentheses. So we get 5x equals 60 minus 12y. And now we can divide each term in this equation by 5 to isolate x on the left side. So we get x equals 60 divided by 5, which is equal to 12. And minus 12 over 5y. So this is the expression for x that we have to substitute in this area equation. So we get area equals, so 12 minus 12 over 5y times y. And now we can distribute the y into the parentheses. So we get area equals 12y minus 12 over 5y squared. Now this area equation has only y in it. Now we can find the derivative of this area equation to find the y values at which the tangent is horizontal, because for maximum area we need to find the y values at which the graph forms peaks, and at the peaks the tangent is horizontal. So we'll find the derivative of this area equation and we'll set it equal to 0 to solve for y. So we'll start with prime of a equals, so the derivative of the first term 12y will be just 12, and then minus, now 12 over 5 is the coefficient in the second term, so it will stay as it is, and the derivative of y squared is just 2y. Now we'll set the derivative equal to 0 and simplify this equation. So 12 times 2 is 24, so we get 24 over 5y. Now we can solve for y by moving this 24 over 5y term to the left side of the equation, and if we do that, the term becomes positive. So we get 24 over 5y equals 12. Now we can cross multiply the 5, so we get 24 equals 60, and now we can divide both sides by 24. So the 24s on the left side cancel each other out, so we get y equals, so 60 divided by 24 is equal to 2.5, and the unit is centimeters. So this is the value of y at which the tangent is horizontal to this area function. Now we have to find now the interval for y. So basically the domain of this area function. Now since y represents the width of the rectangle, so we know that y has to be greater than 0. Now the maximum value for y will be equal to 5, because if we keep moving this point B up, so the maximum it can go up to is point A. But it cannot touch point A because at that point the x value, the length of the rectangle, will become 0. So y should be less than 5. So this is the domain of the area function. Now we'll use the y values 0, 2.5 and 5 to find the y value at which the area is maximum or the largest. So let's start by writing the area function. So the area function in terms of y is 12y minus 12 over 5 y squared. So we start with the lower limit of the interval, so y as 0. So a at 0 equals 12 times 0 minus 12 over 5 times 0 squared. So this is equal to just 0. Now we can use the y value of 2.5. So a at 2.5 equals, so we get 12 times 2.5 minus 12 over 5 times 2.5 squared. So we get a at 2.5. So in the first term we have to multiply 12 and 2.5, which is equal to 30, and then minus, now we have to do 12 divided by 5 times 2.5 squared, which is equal to 15. So a at 2.5 is equal to 15, and the unit will be centimeter squared. Now we can find the value of a at y equals 5. So we'll sub in y as 5 in the area equation, minus 12 over 5 times 5 squared. So a at 5 is equal to 60 minus 60, which is equal to 0. So if we compare the area values we got for these three y values, the maximum area we got is 15 centimeters square, or y equals 2.5 centimeters. Now in this problem, we just have to find the area of the largest rectangle. We don't have to find the dimensions of the rectangle. So our final answer will be, so maximum area of rectangle is equal to 15 centimeter square. So this is the area of the largest rectangle that can be inscribed in a right triangle whose legs are 5 centimeter and 12 centimeter. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.